Welcome to an extraordinary voyage through the cosmos, where the quest for exoplanets unveils the rich tapestry of worlds beyond our solar system. Imagine a universe filled with countless stars, each potentially hosting its own retinue of planets. Today, we explore the captivating realm of exoplanets, planets orbiting stars other than our Sun, and the profound implications of these discoveries. Our journey begins in the early 1990s, a pivotal era when astronomers first confirmed the existence of exoplanets. The discovery of a planet orbiting a pulsar, an incredibly dense, rapidly rotating neutron star, marked a groundbreaking moment in astronomy. This finding not only expanded our understanding of planetary systems, but also ignited a fervent quest to uncover planets orbiting more familiar types of stars. As we gaze into the vastness of space, we encounter a remarkable diversity of exoplanets. From gas giants akin to Jupiter, with their thick, swirling atmospheres, to rocky planets that might bear similarities to our own Earth, the variety is astounding. Some exoplanets are classified as ice giants, composed mainly of substances like water, ammonia, and methane. Others, such as the exotic hot Jupiters, orbit perilously close to their stars, experiencing extreme temperatures and atmospheric conditions. To detect these distant worlds, astronomers employ a suite of sophisticated techniques. The transit method, one of the most successful, involves observing the periodic dimming of a star as an exoplanet passes in front of it. This small but measurable decrease in light allows scientists to infer the presence of a planet, estimate its size, and deduce its orbital period. The precision of this method has been instrumental in identifying thousands of exoplanets. Another vital technique is the radial velocity method, or Doppler spectroscopy. As an exoplanet orbits its star, it exerts a gravitational pull that causes the star to wobble slightly. By measuring the shifts in the star's spectral lines, astronomers can detect these minute wobbles and determine the planet's mass and orbit. This method has been crucial in discovering many of the larger, more massive exoplanets. Direct imaging, although more challenging, provides a direct look at an exoplanet's light, bypassing the star's glare. This technique involves capturing the light reflected or emitted by the exoplanet itself. By blocking out the star's light, scientists can study the exoplanet's atmosphere, surface features, and even weather patterns. Although direct imaging is complex due to the brightness of stars, it offers valuable insights into the physical characteristics of exoplanets. One of the most exciting aspects of exoplanet research is the search for planets within the habitable zone, often referred to as the Goldilocks zone. This is the region around a star where conditions might be just right for liquid water to exist, an essential ingredient for life as we know it. Finding exoplanets in this zone is a key goal in the quest to discover potentially habitable worlds and perhaps signs of extraterrestrial life. The Kepler Space Telescope, launched in 2009, was a game-changer in exoplanet discovery. Its mission was to survey a portion of the Milky Way for transiting exoplanets. Over its operational years, Kepler identified thousands of exoplanets and provided invaluable data on their size, orbit, and potential habitability. The legacy of Kepler has laid the groundwork for future explorations. Enter the James Webb Space Telescope, JWST, a marvel of modern technology and the next frontier in exoplanet research. Launched in December 2021, JWST is equipped with cutting-edge instruments like the Near-Infrared Camera, NIRCam, and the Mid-Infrared Instrument, MIRI. These tools enable scientists to analyze exoplanet atmospheres with unprecedented detail. By studying the light that filters through or is emitted by these atmospheres, JWST can detect chemical signatures such as water vapor, methane, and oxygen that may hint at the presence of life. The study of exoplanet atmospheres is a particularly exciting area of research. By analyzing atmospheric composition, scientists can gain insights into the climate, weather, and potential habitability of exoplanets. This research involves interpreting complex data from various sources and using sophisticated models to predict the conditions on these distant worlds. As we look to the future, the field of exoplanet research continues to evolve. Upcoming missions such as the European Space Agency's Plato and NASA's Nancy Grace Roman Space Telescope promise to advance our understanding further. Plato will focus on finding Earth-sized planets in the habitable zones of nearby stars, while the Roman Space Telescope will study dark energy and contribute to the search for exoplanets. The technological advancements in proposed missions herald a new era of discovery. Innovations in telescope design, data analysis, and planetary probes will enhance our ability to explore and understand exoplanets. Each new discovery brings us closer to unraveling the mysteries of planetary formation and the potential for life beyond Earth. The search for exoplanets is not just about cataloging new worlds. It is a quest to understand the cosmic environment in which our own solar system exists. Each exoplanet discovered contributes to our knowledge of how planetary systems form, evolve, and potentially host life. It invites us to ponder our place in the universe and inspires us to dream of what lies beyond the familiar stars in our night sky. As we continue to explore and unravel the mysteries of exoplanets, let us remain curious and inspired. The universe is vast and full of wonders, and with each discovery, we edge closer to understanding the true scale of our cosmic neighborhood. Thank you for joining us on this journey through the cosmos. Keep exploring, stay inquisitive, and remember that the universe is full of remarkable discoveries waiting just beyond the horizon.